there! I'm Dory, here to answer another one of your questions for this episode of Ask Starbase. Today's question comes from Hannah, who is a student in Mrs. Caselli's class in South School. Hannah would like to know, what are atoms made of? I love this question because it connects so strongly to the fact that science has to be flexible. Like evolution, what we know about atoms is considered to be a scientific theory. These theories are used to explain scientific observations that have been repeated through multiple experiments or tests. However, as technology and techniques have changed throughout history, we have been able to collect more data which we can use to tweak current theories or generate new ones. When it comes to atoms, our understanding has changed dramatically over time. First, we thought that they were just the tiniest bit of something, but still one solid piece. Then, J.J. Thomson conducted an experiment with a cathode ray and electrically charged pieces of metal. When the particles leaving the ray moved towards the positive piece of metal, he essentially discovered the electron. Thomson suggested atoms were more like plum pudding or chocolate chip cookies, where there was a large positive piece with lots of tiny negative ones stuck inside. Then Rutherford conducted his gold foil experiment, where he shot tiny alpha particles at an incredibly thin piece of gold foil. He found that the particles almost always moved through the piece of gold foil, with a tiny number bouncing off. This information taught us that atoms actually contain a lot of empty space, and something dense in the middle. Bohr took Rutherford's idea and the colors emitted by hydrogen gas to suggest that the negative pieces, called electrons, spin around the positive nucleus, like planets moving around the sun. That brings us to modern atomic theory, which started about 100 years ago with Schrödinger's wave equation. He used math to suggest that rather than moving in orbit, electrons behave like waves and are found somewhere within a cloud. This theory states that electrons are likely to be found within a specific area now known as an orbital, with the positive nucleus in the center. Another way to think about this quantum mechanical model would be to imagine your town or city is an atom. Your home is at the center, similar to a nucleus, and you are an electron. While you might travel throughout this atom to visit other people or places, chances are you spend a lot of your time closer to home, so that area would be your orbital, where someone is most likely to find you. Shortly after we got to this idea of the quantum model, James Chadwick conducted an experiment where he found out that when alpha particles collided with beryllium atoms, they produced a heavy particle that wasn't electrically charged, and named this particle the neutron. Now we have our atom, made of positive protons and neutral neutrons taking up a tiny part of the atom in the center, aka the nucleus, with tiny negative electrons moving around outside it. Since that time, we have learned about even smaller subatomic particles known as leptons and quarks through what is now known as the Standard Model of Particle Physics. There are 6 leptons, including the electron neutrino, the muon neutrino, the tau, and the tau neutrino, where the neutrinos are neutral and the others are charged. The 6 quarks are up, down, charm, strange, top, and bottom. The protons and neutrons are called baryons, or particles which are made up of 3 quarks. Protons are made up of 2 up quarks and 1 down quark, resulting in a positive charge, while neutrons contain 1 up quark and 2 down quarks, resulting in a neutral charge. Our exploration of the tiniest parts of the universe is far from over. One of the most recent big discoveries in this area of physics was the creation of a new particle in July of 2012 at CERN's Large Hadron Collider. While this particle was consistent with what scientists predicted to be the Higgs boson, it hasn't been entirely confirmed yet. Who knows what else we will learn about atoms and their parts as we continue to test new ideas. Thank you for watching this episode of Ask Starbase, and a special thank you to Hannah for sharing her question with us. If you have a STEM question, please email it to ask@starbase-ct.com or go to our website, starbase-ct.com, to submit your question. Stay safe and be well. Bye!